Algebra 1, Common Core, Chapter 1 video notes. So if you're following this video note series produced by me, you should know that there's no video for sections 1.1 and 1.4 here. So we're starting with 1-2. So that's Chapter 1, Section 2, which is titled Rational and Irrational Numbers. Let me start with a couple of definitions here. First, a rational number is any number that can be expressed as the quotient or fraction of two integers, a numerator p and a non-zero denominator q. So basically that means that a rational number can be expressed as a fraction, and that fraction has to be integers. Now we're going to talk about types of numbers down here in a minute, the difference between whole numbers, integers, fractions, decimals, squares, it's important number types. So we'll come back to that concept that the fraction has to be integers. But the numerator is the top, and the denominator is the bottom, and the denominator is non-zero, meaning that the denominator cannot be zero, because that causes something that we call an undefined relationship. You'll learn more about that in the future as well. Now, an irrational number is basically not rational, but it is a number, it is a real number, because you do eventually learn about imaginary numbers, but that's not in this course. That's in Algebra 2. But an irrational number is a real number, but it cannot be written as a ratio, which is the same thing as a fraction. So it cannot be written as a fraction, and it's not imaginary. So before we get further into rational and irrational definitions, let's talk about number types. So whole numbers are always rational. They're the counting numbers. They're the, 0, 1, 2, 3, simple numbers. Now it does include 0. Counting numbers are just 1, 2, 3, 4. But counting numbers with 0 included, that's what a whole number is. Integers are that but negative. So we have -3, -2, -1, 0, 1, 2, 3. There are no fractions and no decimals, although we know that that will come into play. A fraction, again, so whole numbers are always rational, a integer is always rational, and a fraction is always rational. A fraction is 3 over 4, fractional. A fraction 3 over 4, it could be positive, it could be negative, negative 2/3, that negative sign could be on the bottom, which is still really the same fraction, right? Sometimes we see it in the middle. When you have a negative fraction, the whole thing is negative, but it could really go anywhere. But the numerator and the denominator can be integers. They can be positive numbers. You could have a negative number over a negative number, but that just works out to be, a positive fraction, because a negative divided by a negative. A fraction really is a form of division, right? Like this 3/4 is 3 divided by 4. But you know what fractions are. Decimals, now here's where we get away from always rational. Decimals are sometimes rational and sometimes irrational. Decimals that are rational end or repeat. Like the decimal 0.5 ends. That's it. It's 0.5. After it, there's nothing. Or the decimal 0.5 repeating. You know that repeating bar where it's like 0.555555555, and it goes to be fives forever. Those are rational decimals because they are equivalent to fractions. Like example, 0.5 is equivalent to 1/2, and so it can be expressed as a fraction. 0.5 repeating, I'm not really sure what that is, but I know that 0.3 repeating, for example, is 1/3. So repeating decimals can be expressed as fractions. I don't know all of them off the top of my head. But if the decimal ends or repeats, that's rational. An irrational decimal does not end, so it goes on forever, and it does not repeat. So something like 0.13724, dot, 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 and the dot, dot, dot here is not that it's 3 repeating, it's just random numbers repeating. It goes on forever, and there's no pattern. And that's really probably the most important piece, is that rational decimals have a pattern, irrational decimals don't. Square numbers are numbers that come from something times itself. The first square is 1, which comes from 1 times 1. Then 4, which comes from 2 times 3. 9, 16, 25. This is 2 times 2, 3 times 3, 4 times 4, 5 times 5. Those are the square numbers. You're probably familiar with those. Those are important to help us determine if radicals are rational or irrational, because radicals are sometimes rational and sometimes irrational, and that's why I put this right before that. And radicals are primarily what we use in these rational, irrational questions in Algebra 1. And so this is probably the most important thing on this page, how to determine if a radical is rational. And the key is that rational radicals is the square root of a square number. For example, the square root of 4, the square root of 9, the square root of 25. These are rational because doing the square root is kind of undoing squared. Like, for example, if you had, the number 7 squared works out to be 49. Well, if you then do the square root of 49, you get back to 7. So squaring something is times itself. Square root is what times itself is 49. And the square root of 4 is 2. The square root of 9 is 3. The square root of 25 is 5, because those numbers squared are those numbers. But if you have the square root of a non-square number, like the square root of 5, or the square root of 20, the square root of 12, there is no number times itself that gives you 5. There's no number times itself that gives you 20. 4 times 5 is 20, but nothing times itself. 4 times 4 is 16, and 5 times 5 is 25. But 20 is not there. These can be reduced. Irrational radicals can be simplified. For example, rad 20 comes out to be 2 rad 5, which we'll talk about in another lesson. But, they're irrational because they're not square. There are some other famous irrational numbers you've probably heard of before. The one I'm sure you all know is pi. 3.14159 and a bunch of other random numbers. We see this a lot in circles and stuff like that. E is another one, which you'll learn more about in Algebra 2. We see it a lot in finance. It's called Euclid's number. But those are famous irrational numbers. All right, so, well, before we get to the operation stuff, going back to a rational number is something that could be a fraction. Now, these whole numbers, I said these are always fractions because you could always put something over 1 to make it a fraction, right? These can always be placed over the integer 1. They're all fractions now. In fact, they're also decimals because you could always put a 0.0 after it, right? So they're all fractions and decimals. And fractions themselves, of course, are fractions. And decimals, again, it depends if they have a pattern. If they end or repeat, they're rational. If there's no pattern or a non-square radical, that's where we have irrationals. Now, this next page, it's a continuation of 1-2. What are the rules for operations? And this is where you see a lot of multiple choice questions on the regions, things like that. A radical times a radical is always, that type of thing. Or a rational times an irrational is that rational or irrational type stuff. So there's a couple of rules that would be helpful here to know. And the first is that a rational plus, minus, times, divide. Now that's your operations. When we talk about operations, addition, subtraction, multiplication, division, those are the 4 operations we're referring to. And a rational with any of these operations is always rational. And so what we're saying is that a rational plus a rational number is always rational. A rational minus a rational number is always rational. A rational times rational, always rational. And a rational divided by a rational is always rational, except there is one exception here. Again, we can't divide by 0. You cannot do 5 divided by 0. That's an undefined situation. Now 5 is rational and 0 is rational, but they don't divide. You can't divide by 0. You can divide 0 by 5, but you cannot divide 5 by 0. 0 can't be on the bottom. So we're going to say that it's always rational, but there is one small exception to that, and that's you can't divide by 0. How about 2 irrationals? So just remember, two rationals is always rational. How about 2 irrationals? Plus, times, so on, so on, so on. The answer here is sometimes. Sometimes rational, sometimes irrational. It can be either rational or irrational. And that's where it gets a little tricky. So like a rational plus an irrational. That can be rational in the I'm sorry, I'm doing 2 irrationals. That's not one of each yet. That's what's next. So let me go back. It's got to be 2 irrationals. So irrational minus or plus irrational. That's possible to equal rational. For example, rad 5 is irrational. But so is negative rad 5. They are both irrational numbers. And you could have positive and negative irrational numbers. But because they're the same with opposite signs, they're going to add to 0, which of course is rational. And of course, we'll see the same thing for subtraction, that you could do, pi minus pi is 0. That's an irrational minus an irrational, but it comes out to be a rational solution. So, when it comes to two irrationals, it could be rational or it could be irrational. There's no solid rule that it's always rational or it's always irrational. The same for multiplication and division. You think of multiplication, you could do something like rad 2 is irrational times rad 8 is irrational, but it multiplies to rad 16, which is rational. Not square, but it multiplies to square. Or you could do division. I mean, you could just do rad 2 divided by rad 2, and anything divided by itself is 1. So that's rational from irrationals. But of course, rad 2 times rad 5 is rad 10. That's still irrational. Or, so when it comes to two irrationals, the answer is sometimes. It depends on what numbers you're working with. Oh, two rational, always rational. Two irrational, it depends. One of each is always irrational. It is not possible to get rational. So if you do a rational plus irrational, it's always irrational. Or rational minus irrational is always irrational. Irrational times rational is always irrational. Or if we divide, it's always irrational no matter what. So it's really the only two irrationals where you have to be careful. It depends on what the numbers is. Okay, so this is our first video in the series, and we're coming up to about 12 minutes. I usually like to shoot for under 10. This one's running a little long, but what we're going to do in class tomorrow is work on this material. The next video is going to be for 1-4, I believe, right? Because there's no videos. Oh, there's a 1-3. The next video is 1-3, and then we're skipping 1-4. But that's it for rational and irrational numbers. See ya.